Okay, now let's move on to the last one. We talk about vector diagrams. Okay, now what's the purpose of vector diagrams? Okay, this is actually to calculate the resultant force. Okay, this is actually to calculate resultant force. So vector diagrams are used to calculate resultant forces. So how do we go about drawing vector diagrams? Generally, okay, what I'll say the first step, okay, let's say for example, let's give an example, okay? Example, maybe I have an object here, okay? There's at this point I got a rope pulling it here at 100 Newton. I have another rope pulling it here at maybe 200 Newtons. Okay, normally okay, then I say the angle between them is maybe 50 degrees. So how do we go about, so the question is, what is the resultant force? And normally they'll tell you, using a vector diagram, calculate the resultant force. Okay, determine the resultant force. So how do we go about doing it? Okay, first you imagine that the box becomes a point. Okay, then next up, determine your scale. Why do you need a scale? Because when you use vector diagram, you need to do accurate drawing. Okay, this must be accurate drawing. So a scale is very important. So maybe the scale that we're going to use here is 1 cm equals to 10 newtons. Okay, try to make the scale as big as you can. Okay, try to make sure that you can make your scale in such a way that you can draw as much, filling up as much of the paper as possible. So what I'll do is, I'll draw a line and I'll label it 100 Newton. Okay, and I'll say that, and what is the length of this line? The length of this line will actually be 10 cm. Next up, I'll take a protractor and then I'll measure an angle of 50 degrees. Okay, this is freehand drawing, so just take note, not drawn to scale, but I need you all to do vector diagram drawn to scale. So I'm going to do is, I'm going to draw a force. This represents my 200 Newton. And what's the length of it? It is 20 cm. Okay, 20 cm. So how do we go about completing the diagram? Okay, sorry, let me try to erase this, make it nicer. Okay, 20 cm. After you have drawn the two forces, and then also labeling the angle, next up, what I need to do is this. Okay, because what we're going to do is we're going to draw a parallelogram. What we're going to do is we're going to draw a parallelogram. So there's actually a principle that can apply. If this is 50 degrees, to complete the parallelogram, you should draw a line here that's 130 degrees. Take 180 minus 50. After you've measured 130, you draw a dotted line. Okay, as long as you want. After that, same thing over here. This angle here, you measure 130 degrees. Okay, then you draw dotted lines again. Okay, draw dotted lines again. Then the last part, you connect the starting point, which is where your object is, to the ending point over here. Okay, with a straight line. You label this as a double arrow and you measure the length. Okay, measure the length of this, and this is actually your resultant force. So think about it. What are the steps that I do? First one, I actually draw two forces with an angle in between. Okay, in between. Second step, what I do is, okay, I take 180 degrees minus the angle, then draw two additional lines. But in this case, these additional lines are actually dotted lines. Okay, so your step 1 is here. Okay, this is your step 1. That is for step 1. Step 2 is actually this. Measure this angle over here, draw this line. Measure this angle over here and draw this line. And your step 3. What do we do in step 3? We draw the resultant force. Okay, and mark. with a double arrow. So where is it? It's actually the one marked in pink. So we draw this and then we mark it with a double arrow. So that's the resultant force. Now, how am I able to measure the resultant force? Because of your scale over here, okay, your resultant force, okay, the magnitude is equivalent to the length of the line. Okay, so you measure this length here and it tells you the magnitude. So for example, if this is maybe 15 cm, so what is the force over here? If this is 15 cm, the force over here will be 150 newtons. So the length determines the magnitude. The next one, okay, the direction. Okay, because force is a vector, it has magnitude and direction. So what's the direction? The direction is equivalent to the angle over here. Okay, sorry, let's use red color. The angle over here. Now, so it's equivalent to the angle. So let's say I measure this angle here is 20 degrees. So how do I say? We can phrase it the statement saying this. Resultant force is 150 newtons, comma, 20 degrees clockwise from the 100 Newton force. You can see here the magnitude is 150 Newton. The direction is here, 20 degrees clockwise from the 100 Newton force. So this is one example, okay, of drawing a vector diagram. Now let's go through one more example. Okay, same thing. You use the parallelogram method. Okay, so we go through step 1, step 2, step 3. So maybe we have a box here. Once again, I like to use box, make it simple and easy. Okay, we can say that an upward force is applied, maybe 40 newtons. Force on the right, exert 30 newtons. Okay, use a vector diagram to determine the resultant force. Okay, determine resultant force using vector diagram. A resultant force using vector diagram. So how do you go about doing it? So let's say first thing first, obviously step 0, which is to choose a scale. So maybe in this case here, I'll say the scale 1 cm equals to 10 newtons. Okay, 1 cm equals to 10 newtons. A little bit lousy, the scale may be a bit small, but never mind. Okay, so what we have here, have a dot. Okay, now upward force 40 newton, rightward force 30 newtons. What is the angle between them? Up and right, the angle between them is actually 90 degrees. So what I'm going to do is, I'm going to draw a force 40 newton upwards, measure 90 degrees, then I'll draw a force towards here. This is 40 newton, which actually be 4 cm. And in this case here, this one will be a 30 cm. 30 newton. So the length will be 3 cm. So we can see I fulfilled step 1. Draw two forces with angle in between. Next up, what I'm supposed to do, I'm supposed to take 180 minus the angle in between, then draw two additional dotted lines. So if this is 90 degrees, the measured angle here will actually be also 90 degrees. Then I'll draw my dotted line. Okay, draw it quite long. Okay, draw it quite long, so that I can find the intersection point. Same thing here. This angle here will also be 90 degrees. 180 minus 90 is still 90. And then you draw your dotted line. Okay, so you are done with step 2. Last one, step 3. Draw the resultant force and mark with a double arrow. So the resultant force is actually from here, this is the starting point, to the ending point over here, the intersection point. So I'll draw a force here. Okay, draw a double arrow. Now, if you measure here, this will actually be 5 cm. And this is actually a 50 newtons. What's the angle over here? Okay, what's the angle? If you should use your protractor to measure. Okay, protractor to measure. Now, okay, if you look at this diagram over here, if you use your protractor to measure, you realize the angle over here is 53.1 degrees. Take note, my angles are measured to 1 decimal place. So what's the resultant force? So the resultant force is 50 newtons, 53.1 degrees anti-clockwise from the 30 Newton force. So once again, you can see here, this is the magnitude. Okay, magnitude. And here is the direction. Okay, this one marks the direction. So this marks the end of your vector diagram. So I actually covered quite a few things here. I covered forces, okay, using F equals to ma. I've covered moments, I've covered pressure, then I've covered vector diagrams. So this marks the end of the understanding force.